In this video, we are going to discuss about ASIC design flow. First, we have to start the design flow from design entry, which enters the application specific integrated circuit by either using a HDL program or schematic entry. The next one is logical synthesis. So here also we uses HDL and logic synthesis tool in order to produce a netlist which describes the logic cells and their interconnections. Third one is system partition, which divides a larger system into ASIC. And the next one is P layout simulation. It is to check whether the design functions properly. And these four blocks come under the logical design. The next one is floor planning. So it will arrange the blocks of the netlist on the chip. Next one, placement. It will decide the location of the cell in your block. And seventh one is routing, which make a connection between the blocks and the cells. Next one is extraction, which determines the resistance and the capacitance of the interconnect. And the last one is post layout simulation, which check whether the design works properly with the added loads of interconnects. So this is a flowchart for the ASIC design flow. So next, I will discuss about the introduction to ASIC. So here we are going to use as the IC only for the specific applications like designing a microprocessor, memory blocks, etc. So since it is for specific application, it is highly cost and it should be produced in the massive volume in order to reduce the cost, and it has to be designed from the scratch, that is from start, right? Since we are using it for a specific application, it has a very less, it will outpace very less chip size. So next we will discuss about the types of ASICs. So I can classify the types of ASICs from full custom, programmable and semi-customs. So the programmable, it get divided to PLDs and FPGAs. So PLDs, I have already discussed what is PLD. PLD means programmable logical device. It consists of PAL, PLA and Chrome. Okay, and let us go for the semi-custom ASIC. So it consists of two types. One is standard cell based and another one is gate array based. And the gate array based is again, it is classified into three types. One is channeled, channelless and structured standard gate array. So first let us discuss about the full custom ASIC. Okay. So here I have already told you the logic cells are made up of made for the specific applications. So the example for the full custom is microprocessor. So here all the mask layer for the interconnections are customized. Therefore, it is very costly and it is very time consuming process. So it has to be used in the high level applications. Here there is no existing cell libraries are used. So everything must be customized. Okay. So fewer full custom ICs are being designed because of the problem with this special part of ICs. So not all the ICs are full custom. That is what I am going to tell. So here mostly they are using bipolar technology because of improved precision. But they have used nowadays they are using CMOS technology for analog circuits because of its high packaging density, and it will occupies a very low power. It will consume very less power. Okay. And the next one is standard cell based ASIC. It is also called as CBIC. It is also called as CBICs. So here it uses pre-designed logics, examples, and or mux, etc., which is known as a standard cells. So it is a flexible blocks. So it is built of rows of standard cells, like a wall built for the build of bricks. So here the designer has to specify only the placements of the standard cells and interconnects in the CBICs. Therefore, it will saves time, money, and it will reduce the risk. Whereas in full custom, the risk is more. Here we can change the transistor size in the cell based ASICs than compared to the gate array based ASICs. So this is a block diagram of the ASIC. So it has a standard cell area which is of fixed flexible size, and here you can see there are fixed blocks. Okay. And the square one at the edge of the die represent the bonding pads. So here the designer can place the sand cells anywhere on the die. So next one is gate array based ASIC. So it is having a predefined transistor on the silicon wafer. So they cannot change the placement of the transistor present on the die. And here the base cell is the smallest repetitive cells of the base array, which is predefined pattern of the gate array. So they can change only the interconnection between the transistor using first few metal layers. So the gate array it is also considered under the semi-custom design. First one is channeled gate array because it is classified in three type, right? So here the wire spacing is left between the transistor. So between the you can see the base cell, between the cell there is a space left out. So here the cell rows are fixed in height, and so the interconnect is customized, and it is also very similar to the CBIC, and the manufacturing time was up to 2 days to 2 weeks. Okay. So next one is channelless gate array. It is also called a C of gate. Here there is no space left for routing between the rows of cell. So the routing is done from above the gate array cell, as we can customize the connection between the metal one and transistor. So that is why it is called a C of gates. Okay. And the manufacturing time is about 2 weeks. Here since there is no space left out for the interconnections, so the logical density is more. So and the contact mask is customized in this one. So the last one is structured gate array. So it is also called as master size or master image. So it has a embedded block of specification is already mentioned while manufacturing itself. Plus it has a gate array rows. Okay. So this embedded block is used for the specific applications. So it has higher area. Okay. Large area. Okay. So it is of lower cost, and it has a faster turnover. So it combines CBIC and MGA, and here the only the interconnect is customized. Here the custom block can be a embedded blocks, but the embedded function is limited. So for example, if it is having a 36K memory is allocated, means if we can't use more than the 36K, right? So if we use only 60K, means the remaining 60K is waste. So that is the disadvantage of this structured gator.